In this lesson, we're going to take a look at something called standard form of a linear equation. Now what standard form is just a different way to write a linear equation. We're very familiar at this point with slope-intercept form, but there are other ways to write linear equations and other ways that we can use them to figure out information. Now standard form looks like this. ax plus by equals c, where a, b, and c are just numbers, constants. And so anything that takes this format where all the x's and all the y's to one side and just the plain numbers to the other, that's something considered to be in standard form, and it means that it is a linear equation. Now, the reason why we want to learn this as well is because sometimes we're dealing with problems where when we create the equation that goes with the real-world situation or the word problem, it's already in standard form. So rather than always having to change the slope-intercept form, it's better if we're a little more flexible and know how to deal with linear equations in other forms. For example, let's take a look at this problem. The school is organizing a car wash fundraiser. They're charging $10 for cars, which the number of cars we're going to determine as X, and $12 for trucks, which we'll call Y. They want to know how many of each vehicle do they need to wash to raise $300. Alright, so let's translate that word problem into an equation. Think about what that would look like. Well, if it's $10 for cars, then what we want to do is do $10 times however many cars we washed, in this case X, because we don't know it at this point. And $12 for trucks. We would do something similar for the trucks. 12 times Y, $12 for each truck we wash. Now, how many of each vehicle do they need to wash to raise $300? Well, if this gives us the total amount of money from the cars and this is the total amount of money from the trucks, then what we can do is add those totals together to get a combined total of 300. And notice how in the simple act of creating the equation from the word problem, we get something that's already in standard form. ax or 10x plus by or plus 12y equals c, 300. Now, let's say, this is where standard form is the most helpful. Let's say we want to actually graph this information, because there's multiple combinations here that'll work. I could skip all the trucks and just wash 30 cars. I could skip all the cars and wash 25 trucks. I could do a combination. So anytime we're looking at multiple answers, it's always a good way of showing it when we can graph it. So here what I've done is I've just created a typical XY coordinate graph. And I'm just sticking to positive numbers because negatives don't make sense in this case. You can't have a negative truck. X, since that was the cars, is we'll put that as the x-axis, cars washed, and the y-axis, trucks washed. Now, rather than using slope-intercept, we're going to use standard form. And standard form doesn't have any of that information slope-intercept does, like the y-intercept or slope. A, B, and C here don't mean anything. But there's a simple trick that we can use. We're going to use the intercepts, both the y-intercept, which we're familiar with, and also something called the x-intercept to graph fairly easily. Let's start with the y-intercept first, only because we're more familiar with that. Now we understand that the y-intercept is where our line, wherever we graph it, will cross the y-axis. And if you think about it, the one thing about any point along the y-axis that's consistent is that the x-coordinate is always 0. You know, if I want to go to here, it's across 0 up to 3. If I want to go up here, it's across 0 up 10. If I wanted to be down here on the y-axis, it'd be 0, negative 2. But regardless of where I want to end up on the y-axis, x is always 0. So what I can do to find the y-intercept is simply take my standard form equation, and since I'm looking for the y-intercept, I'm going to stick 0 in for x. 10 times 0 plus 12y equals 300. Now the reason why a lot of people like this method is because since we're plugging in zeros and we're multiplying with it, zeros have the natural tendency to just make stuff disappear. 10 times 0, we don't even have to worry about it. All we have to do is worry about this part. 12y equals 300. So if I solve that by dividing both sides by 12, I get y equals 25. So right away I get one of the points of my graph. The y-intercept is going to be 25, up here somewhere once I put the increments on the graph. Now, the x-intercept, even though we haven't used that as much, you can do the same thing. The x-intercept is always found on the x-axis. It's where our line crosses the x-axis. And again, the same consistent thing. If you think about all the points anywhere on the x-axis, the one consistency is the y-coordinate is always 0. You know, 4, 0, 10, 0, negative 3, 0. in order to be on the x-axis itself, the y-coordinate has to be 0. So what we do is we take the same equation and we plug 0 in, but this time we plug 0 in for y. And a real easy way to remember it is that with the intercepts, when you're looking for whatever intercept, it's always the other variable you plug in for 0. If I'm looking for the x-intercept, I plug 0 in for y. If I'm looking for the y-intercept, I plug a 0 in for x. Now again, we like these zeros because zeros just make this part of the problem disappear. And all I'm really dealing with is 10x equals 300, which is easy to solve. That would just be x equals 30. Now, this is pretty much all we need. We don't need a slope. I'm just going to use these 2 points because if you think about it, since it's already in standard form, which means it's a linear equation, which means it's going to be a straight line, 2 points is all I need. If I know 2 of the points, all I have to do is connect those with a straight line. Alright, so let's increment the graph here. I think it'll fit if I go, for every 2 squares, I go 5 vehicles. So 5, 10, 15, 20, 25, 30. If I go up to 30, that should be enough. And we'll do the same thing this direction. 5 trucks, 10, all the way up. Now, what I do is I graph my 2 intercepts. The x-intercept once again was 30. So I know wherever I put this line, the x-intercept will be here at 30. In other words, my line will cross the x-axis at 30. The y-intercept is 25. So if I go up to 25 on the y-axis, I know the line will also cross here. And since again, I already know that this is a linear function, I know that this graph is just going to go through these 2 points, and that's all I really need. So if I just make a graph that goes like that, that represents the situation. So if I pick any point along this line, I'll get a combination that works out to $300. So 30 cars washed and 0 trucks washed, 30 times the $10, that's 300. If I pick other points, these also, no matter where I pick, I'll also get a situation that gives me $300. And so that's how we use standard form of linear equations to graph. We find the x-intercept and the y-intercept by plugging in zeros and use those points to draw our line.